This question asks us to draw the line of y equals x on the grid below. If you don't know what the graph of y equals x looks like from memory, then we need to use a different method to find the coordinates for this line. The suggested method here is to draw a table of values. This is what your table of values would look like. Because the question asked you to draw the line from x equals 0 to x equals 5, the top line of the table has x as 0, 1, 2, 3, 4 and 5. What we need to do now is to find the y values that go with each of those x values using the equation of the line that we were given, y equals x. If y equals x, that means that whatever value y is, x is the same value and vice versa. So if we know the value of x, then we know the value of y because they are equal. So for example here, when x is 0, if y equals x, then y must also be 0. So in the table, underneath x equals 0, we can put y equals 0. When x equals 1, if y is the same as x, y equals x, then we can say that y is also 1. Using this same pattern, we can now fill in the x value of 2, 3, 4 and 5. We can fill in the y value that goes with it, because if x and y are equal, when x is 2, y is 2. When x is 3, y is 3. When x is 4, y is 4. And when x is 5, y is also 5. So we've now got the y values from x is 0 to x equals 5, which means we've now got our coordinates to draw our line. From the table, each x and y pair make a coordinate. So we remember that when we draw coordinates, we always write the x value first and the y value second. So our values are x equals 0, 0, xy equals 0, 0, xy 1, 1, 2, 2, 3, 3, 4, 4 and 5, 5. And now we can draw those coordinates onto our axes. So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And what we must remember to do then is to join those up with a straight line through the points, through the middle of each of those points. You'd use a ruler, okay? Use a ruler for that. So that's our line, y equals x, from x equals 0 to x equals 5. This second question is very similar to the first one, but this time we notice that instead of the equation being y equals x, it's y equals minus x. Again, if we don't know what this graph looks like from memory, we think of using another method, and a good method to use here is to draw a table of values. So we look at what the question asks for, our x values from -5 to 5. The next graph that we're asked to draw is the graph of y equals minus x, from x values -5 to 5. This graph is very similar to the graph of y equals x, so we just need to notice that there is a negative sign in front of the x. If we don't know what this graph looks like from memory, we start in the same way as the last question by drawing a table of values. This is our table of values. It ranges from -5 to 5 because that's what the question asks us to draw the graph for. Starting with x is -5. If we look at the equation of the graph, it's y equals minus x. So if x is -5, that means y is minus -5. So together, the two minuses, the two negative signs, become a plus. So we end up with y equals 5. We can do the same thing with x equals -3. When x is -3, we say y equals minus x is the equation of the line. So we've got y equals minus -3. The two minuses together become a positive, make the number positive, so we get y equals 3. Let's look at a positive example. So instead of the negative numbers now, let's try one of the positive numbers. So when x equals 5, what happens? So this time, y is the negative x, x is 5, so we replace x with 5, we substitute 5 in place of x, we get y equals -5. So using the same method, we can fill in the rest of the table, and now all we have to do is we have to plot each of these values. From the table, we can now select our coordinates. We know that when x is -5, y is 5. So on our axes, x is -5, y is 5. When x is -3, y is 3. On our axes, we're plotting -3, 3 here. Okay, slightly off there, sorry. When x is -1, y is 1, -1, 1 here. And finally, when x is 0, y is 0. And the other points you can plot yourself, and then we can join this up. So we end up with our crosses here, 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 and here. So we join them up with a neat line. You'll use a ruler to do this. Okay, we get a straight line graph like that from -5 to 5 on the x-axis. And think about the relationship between that graph and the graph that we drew previously of y equals x. So this is y equals -x. Okay. If you wanted to, you could also call this graph minus y equals x. It wouldn't matter, it would work the same the other way round. So that's y equals -x. So the graph that we drew before this was y equals x. So look back now and see the relationship between those two graphs. Slightly different equation this time. This time we've got a table of values to fill in for y equals 2x minus 1. So this time we've already been given the table of values, and this does happen sometimes. Sometimes you're given a table of values for you to fill in. So we can see here some of the values have been filled in. All we have to do is x equals 2 and x equals 0. So we have y equals 2x take away 1. And they're told here, this time, that we've got to work with x is 0. So we're going to substitute in 0 in place of x. So we have y equals 2 lots of 0, 2 times 0, take away 1. We know that 2 lots of 0 is nothing. So 0, nothing, 2 lots of nothing is 0, take away 1 gives us -1. So when x is 0, y is -1. And then the second question, the second one that they want us to substitute in is they want us to substitute in x equals 2. So we have y equals 2x minus 1, same equation we're given in the question still. And we say y is 2 lots of 2 this time, because we're substituting in 2 for x, take away 1. So y is 4, take away 1. 2 lots of 2 is 4, take away 1 is 3. So y is 3. Now look at that table of values and look at the pattern. Because this is a straight line graph, what we can see is that the y value is changing by the same amount each time. It's increasing by 2 each time. And when you've got a y value that's changing by the same amount each time like that, that shows us that it's a straight line graph. So we can use that as a little check for ourselves. If it's going up by the same amount each time, then we can see it's a straight line graph. Or if we know it's a straight line graph, we can see that it should be increasing by the same amount each time. Now on the next page we're going to draw that graph. So we'll take our values of -1 and 3 across and put them into our table. We know that this is -1 now, and we know that this is 3. We're working with the same equation, y equals 2x minus 1, and we're going to draw that graph. Exactly like we did last time, these coordinates are in pairs. So we can start at this end, or the right end or the left hand side, it's up to you. So this is the coordinate 3, 5. Remember, x goes first, y goes second. We read 3 on the x-axis and 5 on the y-axis. Then we've got 2, 3 here. We've got 1, 1 here. We've got 0, -1, -1, -3, and -2, -5. Okay. And then, because it's a straight line graph, you'll use a ruler and you'll join these points up neatly with your ruler like so. And it asked us to draw it from x equals -2 to 3, so we check that we've done that, and we have.
we've gone between -2 and 3 on the x-axis. Remember, notice this one, this graph, isn't like the last two. The last two passed through the origin, through 0, 0. This one doesn't. And you'll see why that is later. Okay. I've put another question in here now for you to have a go at yourself. So I've drawn the table of values for you. You need to complete the table and then you can have a go at drawing out that graph on those axes. So this time you're doing y equals -2x on those axes. You should get a straight line graph. Okay, and I'll give you a little hint, it passes through the origin, so this one does pass through the origin. The last one that I want to look at is this one. It's slightly different this time, because this time we've got x add 2y equals 4. So you can see on this question that both of the x and the y are on the same side of the equal sign, so it looks different. We can still work with that, it's not a problem, we'll still do this question. So we're going to do it in exactly the same way. So we're going to choose some x values, substitute them in to help us to find the y values. So this one's going from -4 to 4, lots of values to fill in your table. So we have, I'm going to start on the right hand side. The reason I'm starting on the right hand side is because it's easier to substitute in positive numbers than negative numbers, and so we can look for that pattern to help us when we come to do the negative numbers. So I'm substituting in 4. So x add 2 lots of y is 4. So in place of x, we're going to put 4. So 4 add 2 lots of something is 4. So we've got to think, okay, 4 add what is 4? So we know that 4 add 0 is 4. So 2y, this 2y here, must be equal to 0. Because when we do 4 add 0, we get 4. So if 2y is 0, then 1y must also be 0. So we know this value here is 0. Let's have a look at a substitution in another value. Just rub that out. And we'll substitute in another value. So this time we're going to substitute in 3. So x is 3 this time. So 3 add 2y is 4. So we think to ourselves, what do we add to 3 to get to 4? We know this bit must be worth 1, because 3 add 1 is 4. So 2y must be worth 1. So if 2y is worth 1, we know the opposite of timesing by 2. We need to divide both sides by 2. So y must be a half. So here y is a half. And we carry on filling in that table all the way along. Let's have a go at the next. We'll do one more together and then you can fill in the rest of that table and have a go at plotting that. So the next one we're going to get, we're going to do x. I'm going to try x is 2. So x add 2y is 4 still. X is 2. 2 add 2y is 4. So that means that this bit here, we know 2 add 2 is 4, so this bit, 2y, must be worth 2. So if 2y is worth 2, then y must be 1. And hopefully you can start to see the pattern along this y value, along these y values here. We can see that each time it's increasing. If you go from right to left, it's increasing by a half, or from left to right, it's decreasing by a half. So now that we've spotted that pattern, as we go through, we know what we're looking for, and it makes it easier for us to fill that table in. So you have a go at filling in the rest of those values yourself, and then when you come to draw the graph, hopefully you will see that it's a straight line graph when you join all those points up, and you'll know that you've got it correct or not. Okay, hope that helps. Thank you.